In this example, we're given a circuit that contains 3 different resistors and a voltage source that is independent, and I know its voltage is 20 volts, and a current source that is dependent. So this current source depends on this particular voltage across this particular resistor. So let's go ahead and, we're asked to figure out what the V naught is and the power associated with each circuit element. So the first thing we need to do is just assume certain elements or certain currents of voltages going through it. So I'm going to start with the voltage source. So the voltage source in here will have an I associated with it. Let's call it, for example, I voltage source. And of course, we can identify that this is a node and there's a voltage source coming from the current going through the voltage source. For about this resistor, we can say, well, it has a I450, but knowing KCL, we know that the current going in is equal to the current going out. So it is technically the same V of S. I'm just going to highlight it as this is I of V of S. And of course, we need to identify the voltage drop across it. I'm going to say, well, this is V450, for example. And again, we can argue the same type of argument for this particular node. So if I V of S is coming in here, it's the same I V of S coming in here because I only have one way in, one way out. So I can identify that this is I V of S. And it's been identified for me that this is plus minus and this is V of X because this current source depends on it. That's why I was given that. Now we move on to the second part of the circuit, which is right here. So in this part of the circuit, we do have the current going through it. I'm going to call it I, current source, and I know that it's Vx divided by 1. And again, the same argument, well, we'll have to identify the voltage drop across it. So this is plus minus. For example, this is voltage current source. And again, if we actually go in here and we identify this as a node, we will know if this is I current source, that means the current leaving it must be exactly the same. So I'm going to call it I current source. I can call it I with 300, but I'll just be overcomplicating myself. So this is here is I current source. All right. So I think we have, of course, the voltage here is identified already. So we identified everything except one that I left out on purpose, which is the one here, I delta. And I'm going to show you that this particular I delta is pretty much 0. And the reason why is if there's a current coming from this part of the circuit to this part of the circuit, there must be a way for it to come back. And since there's none, so there's no current flowing through this wire. And I can prove it for you just using KCL. So if I just focused on this particular node in here and I just wrote KCL for it. So based on KCL, it tells me, well, I delta is going into the circuit or into the node. And then I have this part of the IVS is also going to the node. But I have this current in here is leaving the node. So it's basically equals I V of S. Of course, this with that goes away, so I delta is equal 0. So simply that here is definitely 0 amp or milliamp. Okay, so there's no current flowing from here to here. So you might be arguing, why would we need this particular wire connecting these two parts of the circuits if they don't share the currents? Well, as it turns out, and you'll see it in electronics courses, this basically connects the ground. So the 0 reference, because imagine, remember, it's like every voltage difference is referential. So there's a voltage a higher voltage and a lower voltage. In here, I'm saying the lower voltage, the ground, for example, the 0 for this part of the circuit should be exactly the same 0 as for this part of the circuit. If I say that the Vx is 5 volts, 5 volts here means the same thing. It's the same exact 5 volts. Okay. All right. So that's the point. So now let's figure out. Now let me summarize what we know and we don't know about the circuit to figure out what we need to compute. Well, I will just go through the elements by one. So I have a voltage source in here, and I know that the voltage source, I'm going to call it V of voltage source, is simply 20 volts, and I know the current going through it is I V of S. And now we can think about this one here. We have a voltage and a current. So technically I have V 450. I don't know that, and I know that I V of S, well, but okay, it's the same I V of S in here, so I don't need to repeat it. And frankly speaking, if I know I V of S, I should be able to know I V 450, so I don't need to know both. But anyway, I'll just keep writing the rest of the elements in here. The Vx, for example, is the same I V of S. So these are now, I finished this part of the circuit with these 3 elements. So let's figure out this part of the circuit in here. So this part of the circuit tells me, well, the voltage across it is V current source, and the current through it is I current source, and that is simply V of X divided by 100. And the last element, which is the V out, and it's the same I current source, the same as the one right before it. All right, so I have all of these. Of course, I do know this value in here, and I do know this value in here. So I have a couple of things that are known. But now, what I need to pay attention to is just focus on how many equations do we really need in order for me to solve this circuit. So taking a look at this, I can't relate the VS and the IS because I know that this is 20, I don't know what this is, so I definitely need to find out the value for this here. But because I need to know the value of that, that means I will know this and that and here. And since Ohm's law will give me the V450 and the Vx, so technically these are not unknown that I should be looking for like at the very beginning because they're the same exact Vs. Okay, so moving on to the next part of the circuit. The next part of the circuit have similar analysis. So this analysis here tells me, well, if you know V of x, which I will know through this one here, which I will know through the Vs, okay, I will figure out what well, I wouldn't figure out what the V of s, this one here. So technically, I need to figure out what that V of s, VSC is. Okay, and the same goes in here. Well, like I can go ahead and say, well, the V output in here is something I'm looking for. The I current source, I need to figure out the current source as well. Yeah, but of course, I mean, I need to know the V of s, so I need another equation to figure this out. And as well, like I'm looking at these, I need the I current source in order for me to figure out the voltage output. So like I need one of them, either this or that. But remember, it's like the I current source in here is the same, and it's based on V of x, and V of x is here, which is based on the V of s. So technically, all I need is this V of s, and this V of s will tell me that, and that will give me this one in here, and this one in here, and I will know this. So the two things that are highlighted in here, which is IV of s and VC of s, these are the two unknowns that I know. And if you think about it, these are the current going through a voltage source or the voltage going across a current source. If I know these two, I know everything I need to know about this circuit. So I need to find out a way to write two equations other than Ohm's law. Obviously, I can write KCL equations, identify nodes, but I just showed you, I mean, I identified this node and I didn't include the I delta, so that doesn't make sense and I don't need to read it. This node in here, this node in here, and this node here, we kind of like evaluated what these means because they're in circuit with the ISC when I actually identified the elements. So that leaves me, maybe what we need to do is we need to write two KVL equations. And in order for me to do that, I need to identify a couple of loops. I can't do a loop that is outside because there's no path that I can actually do this. So the obvious solution is just tell me, well, this is the first loop and this is the second loop, and that's about it. So let's write two KVL equations in here. So the first KVL equation, and I'm just gonna move this one in here. I'm just gonna write it here. So for loop one, it will tell me, well, you get -20 and then plus V450, okay, and plus V of x equals 0. And I can rewrite these using Ohm's law. For example, the V450, if you think about it, it's simply just I450 times the I V of s. Okay, so let me just rewrite this. This is -20. Well, the V450, again, is plus 450 ohms times I V of s. And again, with the passive sign convention, I'm going in here and I'm multiplying by positive. Okay? All right, so moving on, what about Vx? Vx is simply the same. It's 150 times I V of s. Okay, and that should be 0. Again, it's like it's the same V of s and it's 150. So I rewrote everything in terms of a current, and it's one equation, one unknown, so I actually know what Vs is. And I write it, I V of s is simply 1 divided by 30 amps. Okay, so we know what I V of s is. Well, guess what? Because I know what I V of s is, I can figure out IV of s, that means I can figure out what the voltage here and what the voltage in Vx is. It's the same, and of course I can figure out the power consumed by here. And I can compute all of these. So let me just do that. So the V450, for example, in here, let's do that. So it turns out to be that it is 15 volts, and of course I did the same thing with the Vx, and it is just 5 volts. So I know everything I need to know about it for here. So this V of x is 5 volts. That means I can just go ahead and figure out what the I current source is. It's simply 5 divided by 100, and that's basically 1 divided by 20 amps. Okay, so we know that. We don't know what VCS here, but we know that this is simply 1 divided by 20 amps. And of course we know that we can figure out what V out is. Well, V out is simply 300 times that, which is just simply 15 volts. All right, I identified almost everything except the V current source. So, and the way I'm gonna do it is by writing the second KVL in here. All right, so the second KVL here at node 2 simply tells me, well, it's negative V current source plus V out equals 0. And as it turns out, that simply the V current source is equal to the V out. because these are the two elements on this particular loop in here, and we know that V of out, we just computed it to be 15 volts, and that's about it. So we know everything we need to know about this circuit. We were asked to figure out what V output is, and V output happened to be just simply 15 volts. So this is one of the first things we were asked. What about the power associated with each circuit element? Well, for the sources, we need to use P to equals I times V, and for the currents, we have options. All right, so let's figure out the one at a time. So for the voltage source, so P voltage source, if you think about it in here, we have the I and it's hitting the negative first. So it's negative IV of S, which is 1 divided by 30. This is coming from here. We computed that times 20. Which is simply negative 2 divided by 3 watts. Okay, and it's generating power because it's negative. I'll go to the other source in here and I'll just basically do the same type of analysis. The P of the current source is equal to, well, I have the current source and it's actually hitting the negative part first. So negative V current source, which is 15. I didn't write that 15, but it's 15 volts. We figured out this one in here. It's 15 times the current going through it, which is just simply 1 over 20. And this is this guy in here. All right. Which is simply negative 3 divided by 4 watts. It's also generating power. That means the two sources are generating power, and hopefully the other elements are consuming that power that is being generated. So we can compute it for all the different resistors. We have the 450, 150, and 300. So I'll go ahead and compute that for you. Okay. So I went ahead and computed all these for the powers for the 450 ohms, the 150 ohm, and the 300, and I just used the I times V for each one of the cases. And in each one of the cases, I made sure my assumptions are the I is hitting the positive, the I is hitting the positive, and the I is hitting the positive. So it's simply just looking at the values and multiplying them, and we get half a watt, 1/6 of a watt, 3/4 of a watt. And if you sum all these values, they do sum up to 0 because the two power sources, the current and voltage sources, are generating power, and these are consuming power.